We are going to look at how to solve problems by using the Pythagorean theorem and determine whether a triangle is a right triangle. How is the Pythagorean theorem used in roller coaster design? The roller coaster Superman, Ride of Steel, in Ottawa, Massachusetts, is one of the world's tallest roller coasters at 208 feet. It also boasts one of the world's steepest drops, measured at 78 degrees, and it reaches a maximum speed of 77 miles per hour. You can use the Pythagorean theorem to estimate the length of the first hill. Of course, we'd need to know the length from here to here to use Pythagorean theorem. I could use a trig ratio with what they gave us. In a right triangle, the side opposite the right angle is called the hypotenuse. This side is always the longest side of the right triangle. The other two sides are called legs of the triangle. To find the length of any side of a right triangle when the lengths of the other two sides are known, you can use a formula developed by the Greek mathematician Pythagoras. If A and B are the lengths of the legs of a right triangle and C is the length of the hypotenuse, then the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. We're used to seeing this in alphabetical order. A squared plus B squared equals C squared. And generally, the right angles usually C if we're using A, B, and C, and capital letters are used for the vertices, and the lowercase letters A, B, and C are the side opposite those angles. Find the length of the hypotenuse of a right triangle if A is 18 and B is 24. Grab a calculator. 18 squared is 324. 24 squared is 576. Whose sum is 900. And the square root of 900 is 30. Find the length of the missing side. So I have 9 squared plus B squared equals 16 squared. 81 plus B squared is 256. And subtract 81 from both sides. I have B squared equals 175. We take the square root of both sides. On my calculator, I get exactly 5 square root of 7, but our directions tell us to round to the nearest hundredth if necessary. So that is about 13.23. I guess I can label it units for lack of a better name. Whole numbers that satisfy the Pythagorean theorem are called Pythagorean triples. Multiples of Pythagorean triples also satisfy the Pythagorean triple. Some common triples are 3, 4, 5, 5, 12, 13, 8, 15, 17, and 7, 24, 25. Now, if you listen to John Baylor, he will tell you that ACT's favorite triple is 3, 4, 5, which is handy on this problem because I can see that 7 times 5 is 35, 7 times 4 is 28, so 7 times 3 must be 21, and I don't even have to do the Pythagorean theorem. Area of a triangle is base times height divided by 2, so if I have 28 times 21 divided by 2, the 2 and the 28 will cancel out. I very quickly get 294, and I'm left with square units. ACT, is a time test, so any little trick like that can make things go faster for you is great. Little preview into geometry here. A statement that can be easily proved using a theorem is often called a corollary. The following corollary based on the Pythagorean theorem can be used to determine whether a triangle is a right triangle. If A and B are the measures of the shorter sides of a triangle and C is the measure of the longest side and C squared equals A squared plus B squared, then the triangle is a right triangle. If C squared does not equal A squared plus B squared, then it is not a right triangle. Does 7 squared plus 12 squared equal 15 squared? 49 plus 144, does it equal 225? That would be a no. So, not a right triangle. So 27 squared plus 36 squared, does it equal 45 squared? Well, using my calculator, I have 729 and 1,296 and 2,025. When I add, sure enough, it does. If A and B are the measures of the legs of a right triangle and C is the measure of the hypotenuse, then A squared plus B squared equals C squared. And if A and B are the measures of the shorter sides of the triangle and C is the measure of the longest side, C squared equals A squared plus B squared, then we know the triangle is right.